All right. We're going to do a couple of examples of solving equations. I'm going to start off with one step and two step, though I think it makes even more sense for me to start off a little bit higher than that because the process is always the same in terms of your goal. But let me just go ahead and start off with this. When you're solving equations, first off, you're not solving expressions. So you might end up with, and let's just say, for example, an expression. You might start off with, say, x plus 5. But that's just an expression. You can't solve that. In fact, you can't do anything to that. You can't simplify that. You could rewrite that using some kind of, using one of the different properties of addition. But as it stands, you can't solve that. You can only solve it when you set it equal to something. So when you set it equal to, say, some other expression, just like 2. But now I can solve it because the goal of solving is to isolate the variable. I need to get rid of some stuff in order for me to get that. This plus 5 right here has to go away. If that was gone, I would have x by itself. My goal is to have, indeed, just this x by itself. I can do that by getting rid of this positive 5. Now, in order to do that, I need to do the inverse operation of addition, which is subtraction. So if I subtract 5 from that side, because this thing right here is indeed an equation, I need to, whatever I do on one side, I need to do to the other. So if I subtract 5 over here, I need to subtract 5 over here. Let me just draw a line in there to show some separated math. When I do positive 5 minus 5, I get 0. Let me put my equal sign in there. If I am over here and I do 2 minus 5, I get negative 3. And then here I just bring the x down, x plus. So x plus 0 equals negative 3. But whenever you add 0 to anything, you don't change it. So I can just rewrite it as x is equal to negative 3. So that is my solution. I can always check that. By checking, I start off with the original. Since my x is negative 3, instead of x, I write negative 3, and that's plus 5 equals 2. Now, when you're checking, you're just doing one side and you'll get an answer, and on the other side you get an answer. They should be equal. On the right side, let's do that one quickly. It's just 2. There's nothing to do. On the left side over here, I have negative 3 plus 5. That's going to give me a positive 2. Because these things are equal, that means that this right here, this thing that we actually solved for, is indeed the solution. Okay? Let's add to that a little bit. Let me make that a little smaller. Slide that over here. Let's do another example. Let's say, for example, let's do x over 3 is equal to 4. Now again, I have an x that I'm solving for. I need to get rid of this 3. Right now it's being divided, so I must do the opposite of that if I'm going to try to get rid of it. The opposite of dividing is multiplying. So if I multiply this whole side, come on, by 3, if it helps, 3 over 1. If I do it to one side, I must do it to the other, by 3. On the right side, that's easy. 3 times 4, or 4 times 3 is 12. On the left side, what happens to this 3 and this 3? Well, they both cancel out. And so 1 times x is just x all over 1 times 3, or just 3. I'm sorry, 1 times 1. I said 3. I meant to say 1. If I look at that a little further, then I'll have x equals 12. One-step equations.